Hi, Harry. Today we're going to talk about how JavaScript decides what is true and what is false, even if you didn't explicitly tell it anything.
Wait, it figures it out by itself. How does that work?
Exactly. JavaScript is a loosely typed language. That means it often converts values into the type it needs, especially in conditions where a decision has to be made, like in an if statement.
Oh yeah, I've seen that. Like, if value, and that value could be anything?
Precisely. And that's where the idea of truthy and falsy values comes in. Whatever you pass into a condition, JavaScript first checks. Are you true or false to me?
Even if it's not literally true or false.
Yes. In JavaScript, there are only 8 specific values that are considered falsy by default. Everything else is treated as truthy.
8. What are they?
Here they are. False, the literal false value. The number 0, -0, a rare technical case. An empty string, when there's nothing between the quotes. Null, meaning nothing was passed. Undefined, when a variable has no assigned value at all. Not a number, a special value you get when you try something like dividing an apple by 3. And one more, a special 0 used with very large numbers known as big and 0.
So if I say if 0, JavaScript treats that as false?
Exactly, because 0 is one of those falsy values. But numbers like 1, -3, or 10, those are truthy.
What about a string like hello? Is that true?
Yes, any string that contains something is considered truthy, even if it's just a single character or the word 0. As long as it exists, JavaScript says, that's something, so it's true.
But an empty string is false?
Right. If you create a string with nothing inside, that's falsy. It's like asking someone, are you there? And getting total silence.
Are undefined and null the same?
They're similar, but not identical. Undefined means you never assigned a value. Null means you intentionally said, there's nothing here. But both are considered falsy.
And what about that not a number value? When does that happen?
Imagine dividing 5 by the word apple. That gives you nan, not a number. It's a technical way of saying, sorry, can't calculate this. And yes, it's falsy too.
What's that big int 0 used for?
It's used when working with extremely large numbers, ones that don't fit in regular number formats. But if you turn that into 0, it's still considered false.
So everything else is true?
Exactly. Almost everything. Even an empty array or an empty object is truthy in JavaScript.
Really? If I check if empty array, JavaScript still says yes?
Yes, because JavaScript thinks, hey, it may be empty, but it exists, and that's enough to be true.
So how can I be sure whether something will count as true or false?
There's a trick. You can convert the value to a Boolean. Some people use double negation for this, but you can just ask, is it empty, missing, or unclear? Then it's false. Everything else, true.
Awesome. Now I understand how JavaScript makes decisions, even when I just pass in a random variable.
And that understanding is powerful, because conditional logic in JavaScript depends on knowing what's falsy and what's truthy. Once you get that, your code becomes cleaner and easier to reason about. Now that we know which values are true and which are false, let's talk about how this affects conditions in JavaScript, especially when it comes to automatic type conversion.
All right. I've seen strange things, like a number acting like a string, or a string behaving like a number.
Exactly. JavaScript tries to help us, sometimes a bit too much, by converting value from one type to another depending on the situation. That's called type coercion.
Type coercion. Sounds like JavaScript is forcing the value to be something it's not.
That's a perfect way to put it. Imagine you invite someone to a costume party, but they show up in regular clothes. So you throw a quick disguise on them and say, now you fit the theme. JavaScript does the same thing. You're not a number? No problem. I'll make you one.
That sounds kinda sneaky.
It is. Let's say you compare a string that looks like a number, like the word 5, to the number 5. JavaScript says, they look similar. I'll treat both as numbers and say they're equal.
Even if one is a string and the other's a number?
Yes. JavaScript tries to be flexible, but that flexibility can sometimes lead to confusion, especially if you don't realize it's happening behind the scenes.
So it's like a conversation where you assume what someone meant, and you end up being wrong?
Exactly. Imagine someone says 0, and you assume they mean nothing, but maybe they meant the starting point. In code, those little assumptions can lead to big bugs.
So is there a way to avoid these misunderstandings?
Yes. First, know when JavaScript performs type coercion. It often happens in comparisons using the double equals.
So when I use two equal signs, JavaScript tries to guess the types?
Exactly. But if you want to avoid guessing, use triple equals, which checks both the value and the type. It's like asking, are you not only the same on the outside, but also on the inside?
Got it. So double equals is like saying, you look alike, and triple equals means you are the same.
Perfect. Now, type coercion doesn't just happen in comparisons. It also happens when we use values in conditions, like inside an if statement.
So if I write if some value, JavaScript first figures out if it's truthy or falsy.
Exactly. And sometimes it even converts things like strings or arrays to true or false behind scenes. For example, this is a string, then it's true because it exists.
What if I pass in an empty array?
JavaScript says it's an object and it exists, so it's truthy.
Even if there's no data inside?
Yes, that's why developers get confused. An empty array or an empty object looks empty, but JavaScript still treats them as something.
So it's like handing someone an empty gift box. It's empty, but the box still exists.
Exactly. That's why we need to think not just about what a value is, but also how JavaScript interprets it.
This is starting to make sense, but it still feels like a lot to keep in mind.
It gets easier with practice. The key is to learn the most common falsy values, and to be aware of coercion when comparing different types.
So when I compare a number to a string, I need to be careful?
Very careful. JavaScript might try to help, but end up doing something you didn't expect.
Like giving me a cookie when I asked for a sandwich?
Haha, exactly. Good intentions, but not quite what you needed.
So should I always use triple equals?
Almost always. Yes, it's a safe habit. Use triple equals unless you really know why you're using double.
And when I'm writing conditions, just remember what counts as false.
Exactly. Once you understand what JavaScript considers false, and that everything else is treated as true, you'll be able to write clearer and smarter logic in your code.
Okay, but can we go over again what exactly counts as false? Just to lock it in.
Of course. Imagine JavaScript standing at the door of a party. It looks at each guest or value and asks, are you someone or are you nobody? Only a few values get turned away. Here they are, the word false itself, which is officially the opposite of true, the number 0, a special version of 0 with a minus sign in front, an empty string, meaning a pair of quotes with absolutely nothing inside, the value null, which means there's nothing here, the value undefined, meaning we never gave this anything at all, a special result called not a number, which happens when you try to divide something like a word by a number, and a very rare kind of 0 used with super large numbers.
So they're all like people without invitations, not allowed into the true zone?
Exactly. They may look different, but JavaScript treats them all the same, as nothing. Everything else, even a completely empty container, gets welcomed in because it exists.
What if the container is totally empty?
JavaScript still sees it as something real. An empty box is still a box. That's why things like empty arrays or empty objects are treated as true. As long as a container exists, JavaScript says, good enough.
So if I say, check if this empty array exists, it says yes?
Exactly. It says, hey, I see the box, even if there's nothing inside.
That's so weird. I'd expect it to be false since it's empty inside.
And that's what makes this tricky. What feels empty to us might still be true to JavaScript.
It's like handing someone a gift box with nothing inside, and they say, thanks. It still counts.
Haha, perfect analogy, even if the gift's a bit underwhelming.
And what about comparing different types, like numbers and words? JavaScript tries to help, right?
Yes, sometimes a little too much. When you compare values using the equal sign written twice, JavaScript says, "Let me help you. I'll try to make them the same type first, then compare."
Like dressing people in matching costumes before judging if they're alike?
Exactly. If one value is a word 5 and the other is a number 5, JavaScript goes, "Let's just pretend they're both numbers. Looks good to me."
But that can lead to mistakes, right?
Definitely. That's why many developers avoid using double equals. Instead, we use triple equals, which means I want to compare both the value and the type.
So double equals is like saying, you kinda look alike, and triple equals is, you're actually the same?
Exactly. Triple equals is much safer.
And when we check something inside an if, JavaScript silently decides whether it's true or false.
Yes, it looks at the value and quietly asks, "Is this something? If yes, proceed. If not, skip."
Even if it's an empty field?
Yes, that's where beginners often get confused. Something might feel empty, but if it exists, JavaScript still treats it as true.
So we need to know what JavaScript thinks is nothing.
Exactly. That's the heart of this whole topic. Understand what values are false, and you'll know how JavaScript makes decisions.
Wow. I used to get confused when things didn't behave as expected. Now I see JavaScript was just making assumptions for me.
With the best intentions. But the clearer you write your conditions and comparisons, the fewer surprises you'll face.
Thanks, James. I finally get it now.